So welcome to ChemDraw. This is the kind of screen that you'll get when you first open the program. I've made it a lot larger just because it's easier for me to see and perhaps for you to see as well. The drawing toolbar is over here on the left. There are other tools up here that will become somewhat self-evident. Usually the first thing that I'll do is I'll come over here to File, and I'm just holding down the left mouse button. I'm going to apply the document settings from ACS document 1996. These are the industry standards for American Chemical Society journals. You can change a whole bunch of other settings if you wanted to. But it's generally easier to just use the settings that somebody else has come up with. So what I'm going to show you how to do this morning is how to draw the Lewis dot structure of CO3 2-, the carbonate ion. So let's go ahead and type that in. Now, you want to make sure that you use proper subscripting and superscripting, because you're a chemist and not a member of the general public. So there's the carbonate ion. Alternatively, I could have clicked on this icon from the very beginning, and now if you watch, if I go CO3, it automatically subscripts the 3 because it recognizes that you're trying to draw a chemical structure or a chemical formula. And that's what that little symbol means. Unfortunately, it's not perfect. If you draw the 2 in there, it thinks that you're talking about CO32, although it does superscript the minus. So the easiest thing to do is to just highlight the 2 and hit the superscript key. So there's my carbonate ion. Carbonate ion gets 24 electrons, and so when you're drawing it, you need a central carbon with 3 surrounding oxygens. So the bond icon is here, so I need to draw a central atom with 3 bonds to it. So I draw my central atom with my 3 bonds to it. And you want to try to keep things as symmetrical as possible. I'll show you some shortcuts on how to do that in a subsequent lesson. But I want to now label the central atom as a carbon. And you notice when your cursor gets close to either the intersection of lines or the end of lines, the computer sort of realizes, oh, you want to put something there. So if I click with my left mouse button, I can add a carbon. On this atom, I want to have an oxygen, so I enter oxygen and then hit the return key. And now I can manually enter the oxygens here and here, but the computer will also recognize whatever your last atom label was. So if I double click, then an oxygen automatically ends up there. Now I just want to make this a little bit larger for you so that it's easier to see. So when you remember, when you're drawing the Lewis structure, you draw the central atom, in this case 3 surrounding atoms, then you add the electrons to the surrounding atoms. So I've got 24 electrons, I've used 6 of them. That means that I have 18. So I've got some lone pairs. Lone pairs are in this menu here. There are a lot of other sub-menus that you can play around with, and even more than you think. We'll gradually get to those. But for now, I can draw anywhere and I can get a lone pair. I can put a lone pair on this carbon, for instance, even though it doesn't really have it. If you get close once again to an atom, the computer will recognize that that's where you want the lone pair to show up. So I'm just clicking once I get on the oxygen, and you notice how it automatically positions them. If you don't want to do it that way, if I click and hold down and just sort of move the mouse around, it will automatically rotate the lone pairs. So there's my lone pairs. And if you add up all these electrons, you'll realize that you do indeed have 24 electrons. Now, the problem is that this carbon does not have an octet. So you need to use one of the lone pairs and form a pi bond here. There are a couple of ways of forming pi bonds. You can start with one atom, hold the left mouse button down, and move to the other. That'll do it. Or, let me just erase that. If I go to the middle, the computer will once again recognize, oh, you want to put a pi bond there. And I just click, and it adds the pi bond automatically. The last thing you should do is you should put the formal charges in. So the formal charge is also where the lone pairs are. I need a minus charge on that oxygen and a minus charge on that oxygen. And there's your structure. Now, what can you do with this? Well, you can copy it and paste it. So if I wanted another one of it, or if I wanted to modify this in some way, and instead of having oxygens, I can put sulfurs in just by typing in one sulfur and then double clicking on the other oxygens. That automatically changes the label. Now I can move this around if I wanted to, or I can type Command C if you're using a Mac, and that's now copied this to the clipboard, and I can paste this into all sorts of different documents. So I could paste it into a Microsoft Word document or a PowerPoint, or I can stick it directly into an email. The one document that you can't import these directly into are Google Docs, and I don't know why that is. So unfortunately, if you need to get a structure into a Google Doc, you have to take a screenshot of the structure. But otherwise, you can import them directly into a Microsoft Word document. So that's the introduction for how to use ChemDraw.